Hey all, this video goes back to building exponential models with 2 points, except this time we're changing it up a little bit. We're not going to be writing the exponential model. We're going to be converting that exponential model over to a logarithmic model. So go back and check out that other video if you haven't figured out how to write the exponential equation yet. But anyways, let's move on. So this problem had to deal with hours milk stays fresh based off of the temperature. And we came up with this equation here, H equals 42.933, T minus 22. And that hours is based off of the temperature. So now what we're going to do is we're going to write an equation in which the temperature is based off the hours. So in order to do that, we have to go ahead and start with the idea that, hey, we have an exponential equation, which in its most simple format is the base with an exponent equals to a value. And whenever we have that and we want to go and look for the temperature, which is going to be up in the exponent, we're going to need to use a logarithm in the end. So we're going to have a log base value and then exponent. And I'm writing this down for reference as we go through the video. So let's go ahead and let's write down H equals 42.933 to the T minus 22. And just as a reference, we go back to what we wrote down. We need a base, an exponent, and a value. And we do have a base, we do have an exponent, we do have a value, but we have this 42 over there. So the first thing we're going to do is we're going to get rid of that 42. And the way we're going to do that is we're going to divide it off. So we're going to divide by 42. So I have H over 42 equals to 0.933 to the T minus 22. Now, at this point, notice I got rid of that 42. And since this is gone, I now have a value, I have a base, and I have an exponent. We can write this out as a logarithm, and that's what I want to do. So I'm going to follow the format over here on the right. That talks about that outlines the logarithmic format, which is right there. I'm going to say log. I'm going to put the base, and the base is 0.933. I'm going to put the value next. The value is right here, which is H over 42. And I'm going to set that equal to the exponent, which is T minus 22. Okay. Now, I still haven't solved for T. I haven't written the equation based for T. I got to get rid of that minus 22 that's attached to the temperature, and we're going to do that. So let's go ahead and add that 22 over. Once I do that, that cancels out, and we get this statement, this beautiful statement, log 0.933 H over 42 plus 22 on the outside equals to T. Now, did we do it correct? There's only one way to check if we've done this correct, y'all, and y'all know what it is. You know exactly what I'm going to say. Let's go to desmos. So we're going to come over here. We're going to go to desmos, and we're going to type in our function. The first one, I believe, was hours based off of temperature. So let's go ahead and call that one H. Let's go ahead and call this one T of X, and we will flip it around. So let's type that in. I'm going to type log 0.933 H over 42. In order to get that log, I'm going to hit on the keyboard. We're going to go over to functions. We're going to look for miscellaneous, and we're going to go down to log with a base. Once we have that in, now I can put that 0.933. I can put X over 42, and then I can go ahead and add, it was to add 22 in there. And then I'm going to turn on the original equation. Now, once I turn on that original equation, check it out. We need to see if they're exactly inverses of each other. We've done this correct. We do that by saying y equals to x. One side reflects onto the other side. That means we've solved for the alternate variable perfectly. Now, if you did want to check that just a little bit further, we take the first function and we just mix in the second function. So we do a composition. And if that y equals to x line glows, we've got a nice little setup where our equations are done correctly. So let's go ahead and turn those off, except for the second one, the logarithmic function. And let's just answer one simple question. Okay? It says, if a container of milk sours after 130 hours. 130 hours, that's our hours, that's our H. Okay, so if that's the case, H equals to 130, right? What was the temperature? We need to know the temp. Well, guess what? H is right where our X normally is, and our temperature is normally where our Y is. So let's go plug 130 in as an X value on Desmos. And that's how we're going to handle that. Nice and easy. So I come over here. I'm going to go to my log function. I'm going to say, let's say X equals to 130. Check it out. We got some stuff over here. It looks like 5.708. Okay. And then we come back over here. There's another way we can do this. I can say T of 130. I can use the function notation. It's going to calculate it. So 5.708. Let's go 5.71. Let's come back here. We're looking for the temperature. I'm going to write this down. It is 5.71, and that is Celsius in order to answer this question. I hope this helps. I hope this gets you all to be able to write a logarithmic function from an exponential equation. We can do this stuff. Don't forget, don't just be good, do good.